Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. Above you, there is a quiet face that has never blinked. A pale, constant circle hanging gently in the dark. It does not flicker like stars, nor surge like the sun. It simply remains still, old, familiar. The moon. You've seen it since childhood, maybe, even before you had words for it. First, it was just a glowing dot in the sky. Then, a shape to trace, a story to learn, a secret to wonder about. Some call it a silver coin. Some say it looks like cheese. Others see faces, or rabbits, or lost things frozen in craters. And for centuries now, for tens of thousands of years, humans have looked up at the moon and asked, what is that? Why does it follow me? Why does it change shape but never leave? The truth is, the moon has always been a companion, not just in poetry, not only in stories, but in physics, in oceans, in time itself. It isn't just beautiful, it's essential, and yet it is also drifting away. But we'll come to that later. First, let's sit with it as it is. Tonight, the moon might be waxing, growing larger night by night, or maybe it's waning, shrinking into a shy sliver. It may be full and luminous, painting silver onto rooftops and rivers. Or it may be just a whisper of light, barely clinging to the sky. Whatever shape it's in, the moon is always the same moon. One face, one orbit, one quiet path. It does not spin like the earth, or rather it does, but in such a precise and perfect way that we only ever see one side, the same side, every night. Always. That might seem eerie at first, like it's frozen, unmoving, but really, it's dancing in sync with us, locked in a rhythm called tidal locking, a gravitational embrace between Earth and moon that has lasted for billions of years. Imagine two dancers holding hands, turning in a circle, never letting go. That's what the moon does. It moves around us, but always keeps its same face pressed forward. It's like a gentle nod that never ends. And because of that, it's a whole half of the moon we never see from Earth, the far side, once called the dark side. Though it gets as much sunlight as the near side, we just can't see it with our eyes. For thousands of years, that hidden half was a place for imagination, the home of secret cities, alien outposts, strange gods. It wasn't until 1959 that humans finally saw it thanks to a Russian spacecraft that snapped pictures as it flew past. Even now, it feels mysterious. But here on Earth, we've built our lives under the visible face, the one we've painted, studied, worshipped, sung to. It's the one that guides tides, marks calendars, and watches over our sleep. Before clocks, people used the moon to tell time. Before maps, they used it to guide journeys. Its cycle of phases, new moon to full, and back again, became the heartbeat of ancient civilizations. Lunar calendars ruled planting seasons, religious festivals, harvest rituals. Even today, holidays like Ramadan and Easter follow the moon's rhythm. The moon doesn't just mark time, it creates it. Because of its pull, its gravity slows down the Earth's span, not in a way you'd feel, but in a way that matters. Long ago, Earth spun faster, days were shorter, but the moon, with its constant tug, acts like a brake, just a soft, steady pressure on the planet's turn. That same tug pulls on the oceans. You see it in the tides. The moon's gravity lifts water into gentle hills, one facing it directly, the other on the opposite side. As Earth turns, these bulges move around the globe, creating high tide and low tide in a never-ending cycle. It's not dramatic, it's not loud, but it's constant. Can't. It shapes the world. Without the moon, tides would be tiny. Oceans would lie flatter. Coasts would change. Many forms of marine life who depend on the rise and fall might never have evolved. And Earth itself might wobble uncontrollably. You see, the moon helps keep our axis stable. Without it, our tilt could swing wildly over millions of years. Sometimes we'd tilt more, sometimes less, which means climates would shift. Seasons might vanish. Ice ages could come without warning. The moon doesn't just orbit us, it anchors us. It's easy to forget that as you glance up casually during an evening walk, to see the moon as decoration, a sky dash ornament. But no, it's a partner. The moon has seen every night you've ever lived through. It lit the skies when mammoths roamed. It shone on the sails of early explorers. It watched as cities rose, fell, and rose again. And through all of that, it kept drifting, just a little, a few centimeters each year, tiny, UNNOTICEABL. But when you measure across eons, those centimeters become miles. The moon used to be closer, so close in fact, that the tides it caused were enormous. Waves surged higher, days were shorter, Earth spun faster, and the moon circled like a loyal but energetic child. Now, it's calmer, more distant, okay, but still bonded. Scientists discovered its drift using lasers. Yes, lasers. In 1969, astronauts on the Apollo 11 mission placed a small reflective panel on the moon. Later missions added more. Today, scientists fire lasers at those reflectors from Earth's short bursts of light. They bounce back by timing how long it takes for the light to return. Scientists can measure the distance to the moon with millimeter precision. And what they found is startling. The moon is slipping away at 3.8 centimeters per year, about an inch and a half. That's faster than we thought. It won't fly off anytime soon. It won't vanish in your lifetime, or in the lifetime of your grandchildren's grandchildren. But it is leaving, slowly, gently, inevitably, like the tide retreating, like breath after a long sigh. This isn't cause for panic, just a reminder that even things that feel eternal like the moon in the sky are changing, drifting, becoming something new. The moon will never be gone completely, but someday, perhaps billions of years from now, Earth will no longer spin, not like it does now. Its rotation will slow so much that one side always faces the moon, and the moon, in turn, will stop drifting. They'll lock eyes forever, both frozen, in a tidal embrace. Two companions caught in a final, motionless dance. But for tonight, the moon is still there, just as it was yesterday, just as it will be tomorrow. It follows you on your evening walk. It watches from above your window. It sends a soft glow onto the pages of this story, and maybe, just maybe it remembers you too. You too. Before the moon was your quiet companion in the sky, before it pulled on the tides, before it traced soft silver onto nighttime rooftops. It was fire, not light, not peace, not orbit, but collision. Not all births are gentle. Some come with a scream. To understand where the moon came from, you have to go back to the beginning, to a time when Earth itself was young, just a newborn planet, barely cooled, spinning wildly in a crowded, violent solar system. It wasn't calm. It wasn't blue. It was red hot, okay? Bubbling with molten rock, bursting with heat and gases, okay? Its crust was thin. Its air was heavy with carbon and steam, and it was vulnerable because the early solar system was full of other young planets, two half-built spheres crashing into one another, all trying to find their place in orbit around the sun. There were collisions everywhere, and one of those was with Earth. They called the thing that hit us Thay, a Mars-sized object, maybe larger, traveling fast, drawn by gravity, on a collision course with a very young Earth. The impact was not a tap. It was a cataclysm. An entire planet slammed into Earth at an angle, cracking our surface open like an eggshell. It didn't destroy Earth, but it did change everything. The crust shattered. The core was jolted, and a colossal amount of debris, molten rock, metal, was thrown into orbit. An earth-wringing cloud of fire. That cloud became the moon. Not immediately, not cleanly, but slowly. Over time, that ring of molten debris began to cool. Particles clumped together. Gravity did its work. What had been chaos began to condense, drawn inward, pulled tight, and somewhere in that swirling halo of fire and dust, a sphere began to form. This was not the calm white circle you know now. This newborn moon was still red hot, still forming, still scarred by its own creation. It spun faster than it does today. It hung closer to Earth, so close that its gravity pulled terrifying tides across the surface of our oceans. Progress. Earth and moon were locked in an intense gravitational relationship, fast, fiery tidal. The moon may have been 15 times closer than it is now. It would have looked enormous in the sky, maybe filling half of it, and it moved quickly. But the violence of the beginning gave way to stability. Gradually, the moon cooled. Its outer layers hardened. Molten plains solidified into the dark splotches you can still see today. Those wide, gray patches are called Maria, the Latin word for seas. Not actual water, but vast plains of solidified lava. They tell the story of a world that was once hot and restless, ain't now, mostly still. The moon's face became scarred, not just by its own formation, but by constant impacts. You've seen the craters, tiny meteorites, huge asteroid strikes. They all left their marks, and because the moon has no atmosphere, no wind, and no rain, those marks never fade. Every crater is a memory, a scar from a time when space was not a silent ballet, but a dangerous storm. And yet somehow, from all of this chaos, the moon found its place. It began to orbit smoothly. It slowed its spin, locked into rhythm with Earth. Tidal locking happened early, within the first few million years. The same side of the moon always faced Earth. Even then, it was like they made a quiet agreement. You pull on me, I'll turn. Just right. You won't lose sight of me again. And Earth, it changed, too. The moon's gravity helped stabilize our planet's tilt, which shaped our climate, our seasons, our variability to support life. It pulled on our oceans. It slowed our span. That's what's so extraordinary about the moon's birth. It wasn't just violent, it was transformative. The collision that formed the moon likely also gave Earth its iron-rich core, its layers, its magnetic field. It helped Earth become Earth, so the moon isn't just a sidekick, it's a co-creator. It was born from our body, and it shaped the one we live on now. The rocks brought back from the Apollo missions confirmed this connection. Lunar samples share nearly identical isotopic signatures with Earth rocks, proof that they came from the same source, the same ancient fire. Imagine that. You walk on a planet that once lost a piece of itself to the sky, and that piece has watched over you ever since. It's no wonder ancient cultures gave the moon so much meaning. Even without knowing the science, they sensed its power, its connection to Earth, to water, to life. They saw it as a goddess, a guardian, mirror, and they were right, because the moon reflects not just light, our own beginnings. It is a fossil of creation and changed for billions of years. Even now, it still drifts, still pulls, still watches, still remembers fire. There's something poetic in that the same moon you see tonight was once a flaming cloud of destruction, and now it writes light across your sky like a lullaby. That something born in violence can become a symbol of peace. It reminds you that change is slow, that orbits take time, scars can become beauty, and that sometimes even the wildest beginning can become the calmest companion. So tonight, if you find yourself outside, if the clouds part just enough to see the moon, let yourself pause, let your breath slow, and know you are looking at a piece of earth that once burned, okay, and now glows softly just for you. The moon may be drifting away, but it's not running, not escaping, not fleeing into the night. It's still tied to us gently, visibly, but undeniably by gravity. Not the kind of gravity that drops apples from trees, but a subtler pull, a cosmic thread that tugs across 384,000 kilometers of space, a silent handshake between two old companions. You can't see this tether. There's no rope, no chain, no shimmer of light, but it's always there, keeping the moon in its dance, keeping Earth in balance. It's easy to forget how much gravity shapes your life, right? Now, it holds you to your chair. It lets water fall from your faucet, keeps the atmosphere wrapped around your planet like a blanket. But gravity doesn't just work on the small scale. It stretches, it connects, it holds the moon in place, not tightly, but tenderly. And Earth's gravity isn't the only one pulling. The moon pulls back. That's why there's no runaway, only a careful, shifting balance. The moon wants to drift, and it does, but Earth's pull shapes that path, bending the moon's journey into an orbit, not a straight line away, but a slow spiral outward. If Earth didn't pull, the moon would leave. If the moon didn't pull, Earth would spin too fast. But together, they've found rhythm, an exchange of forces. This is what scientists call tidal friction, a quiet transfer of energy from Earth's spin into the moon's motion. It sounds complex, but think of it like this. Earth spins, it's dragging its oceans along with it, the moon's. Gravity pulls those oceans into tides bulging toward it. But because Earth spins faster than the moon orbits, those ocean bulges are slightly ahead of the moon's position in the sky. That extra pull from the bulge tugs on the moon, gives it a gentle push. And over time, that push adds up. The moon gains energy. It drifts outward. Meanwhile, Earth gives up some of its own energy. It spins a little slower. Its days get a little longer. They trade motion in the same way dancers adjust to stay in sync. Push and pull, give and take. A perfect tension that keeps the whole system moving gracefully. And it's been happening for billions of years. When the moon first formed, days on Earth were just 5 hours long. The planet spun so fast that shadows barely had time to stretch. Sunrises came quickly. Nights were short, and tides surged violently. But as the moon pulled, Earth slowed. Now, days are 24 hours. The tides are calmer, and the moon is further away, still pulling, still drifting, still dancing. You can measure this drift precisely. 3.8 centimeters per year. Not much, just about the width of your thumb, but across millions of years. It matters. The moon is now 18 times farther from Earth than it was when it formed. And as it drifts, the tether stretches, but it doesn't snap, because gravity is patient. It allows for change. It doesn't demand stillness. It simply holds on, even across great distance. The moon orbits Earth, not in a perfect circle, but in an ellipse, slightly oval, sometimes closer, sometimes farther, but always returning. It doesn't fly off, doesn't fall in, because the tether knows exactly how much to pull. It's a kind of cosmic trust, and the moon isn't alone in this. Every planet with a moon has the same conversation. Jupiter, with its dozens of moons, each one in tension, each one listening to gravity's whisper. Saturn, too, its rings, not solid, but made of countless tiny objects, each pulled into place by gravity's gentle persuasion. But Earth and its moon, that relationship is special because it's not just about orbit, right? It's about balance. Without the moon's pull, Earth would wobble. Not a big wobble, but enough to make climate unstable, enough to shift seasons wildly, to turn Earth into a planet less friendly to life. The moon keeps Earth upright. It anchors our tilt. It's like a weight on the end of a spinning top, slowing the sway. It's keeping things steady. It has done this for 4.5 billion years, long before humans, long before oceans as you know them, before plants, before animals. Okay, when the Earth was still young, still unsure of its place, the moon was already pulling dot. And now, now it still does, even as it drifts, even as it slips away centimeter by centimeter. It pulls, it creates tides that stir the oceans. It shapes the rhythms of marine life, the migrations, the hatchings, deep sea dances. Some coral only spawn during certain lunar phases. Some birds navigate by moonlight. Some trees bud or bloom in sync with the moon's cycle. The gravitational tether isn't just physics, it's poetry. It flows into everything, from the waves that kiss the shore to the heartbeat of our time, even the months on your calendar. Moons trace back to the lunar cycle. You've built your cultures around its pull. You plant by the moon, you harvest by it, you celebrate, mourn, dream, and measure by it. And still, it drifts, but not because it's leaving you, only because the tether allows it to grow. That's the beauty of gravitational love. It doesn't imprison. It doesn't demand closeness. It allows space so that both bodies can evolve. And as the moon grows more distant, Earth grows calmer. Someday, billions of years from now, the two will reach perfect sync. The moon will orbit once for every Earth day. Earth will rotate just once every 47 current days. They will face each other, always. No more drift. No more change. A cosmic stillness. But until then, they keep moving, bound by gravity and grace. So when you look up tonight and see the moon rising slowly over rooftops or trees, remember the tether. Remember that invisible line, quiet conversation between rock and rock, between mass and motion, between Earth and moon. It's still happening right now, while you breathe, while you dream, while you sleep, and somewhere deep inside you, in your bones, your cells, your blood, that same tide stirs softly. You are part of the pull, part of the peace. You are held by the same gravity that has guided this dance for longer than memory and longer than time. The tide is not loud, does not crash with rage, nor demand your attention like thunder might, but it is constant, twice a day, in every bay, every inlet, every distant shoreline. It comes and goes, as if Earth is exhaling slowly. This rhythm, so old it predates history, is the moon's quiet gift to Earth. It is easy to think of tides as water moving in and out, but that's not quite what's happening. The oceans don't surge forward and then retreat. Instead, Earth turns beneath a bulge of water, a bulge pulled toward the moon by a gentle, visible force that has shaped life since the very beginning. The moon's gravity pulls on Earth, not just the land, but especially the oceans, which move more easily, stretching toward the lunar tug. Imagine it like a soft breath rising over the sea, lifting the water just a little higher on the side facing the moon. And, strangely, beautifully, another bulge forms on the opposite side of Earth too, because while the moon pulls the oceans, Earth itself is pulled slightly as well, leaving the far side's water behind, raised in relative relief. So at any given time, there are two high tides on opposite sides of the globe, one facing the moon directly and one quietly trailing behind. And as Earth spins, these bulges seem to move, sweeping around the planet in a slow, watery dance. But it's not the oceans that are racing, it's us. We turn beneath them. It takes Earth about 24 hours to rotate once. And the moon, it orbits Earth in about 27.3 days. This difference in speed is where the story deepens, because Earth spins faster than the moon orbits. The tidal bulges aren't perfectly aligned with the moon. They're pulled slightly ahead, always trying to get ahead of the game, and that small offset matters. It means the moon is constantly being tugged forward, gently, consistently, by the very tides it creates. And that tug? It gives the moon energy, the momentum. It nudges it farther out, bit by bit, year by year. This is tidal acceleration. And it's why the moon is slowly escaping, inch by inch, from Earth's embrace. But this gift of energy is not one-sided. Earth pays for it. It loses some of its own spin. Its tug slows Earth ever so slightly. Its day becomes just a fraction of a second longer. You can't feel it. For over millions of years, this subtle friction adds up. 1 billion years ago, a day on Earth was just over 18 hours long. The moon hung closer, its pull stronger, its tides more violent now. The moon is farther out. The tides are gentler, but still powerful enough to move entire oceans. Back and forth twice a day. Imagine that. All that motion, all that churning. Water, caused by the silent presence of a moon you can't even feel pressing on your skin. But the Earth feels it. Coastlines feel it. Fishermen who rise before dawn to catch the tide. Whales who migrate in rhythm with the moon. Crabs that scuttle to shore under its glow. Turtles that lay their eggs when the tide is just right. Even corals, silent and still, release their spawn in lunar sync, a soft explosion of life. Timed to the pull of the moon, it is one of the oldest clocks in nature. And yet, it isn't just water that moves with the moon. The land itself bulges slightly. Solid Earth pulled a few centimeters each day by the same gravity that sways the oceans. You won't see it with your eyes. You won't feel the ground stretch beneath you, but it happens, quietly, rhythmically, the entire planet breathing in sync with the moon. That's slowly drifting away. This dance affects more than tides. It helps keep Earth stable. Without the moon, Earth would wobble on its axis. Its tilt would vary wildly over time. This tilt, which now rests at a gentle 23.5 degrees, is what gives us our seasons, the gentle changes in light that define spring, summer, autumn, and winter. Without the moon's stabilizing pull, Earth's axis might lean dangerously, or flip entirely over eons. That would mean catastrophic climate changes places that once had mild weather swinging into ice ages or unbearable heat. The moon keeps Earth steady, anchored, predictable, and the tides it pulls are not just oceanic or seasonal. They are emotional. The moon rises, and poets write. It glows, and lovers gaze. It waxes and wanes, and cultures celebrate its phases. In Japan, the full moon is called Tsukimi, moon viewing. In ancient Greece, it was associated with Artemis, goddess of the hunt. In many Islamic cultures, lunar calendars govern the flow of life and ritual. And in modern science, the moon remains one of the first places we reached beyond Earth. Its tides touch everything, from saltwater estuaries that nurture life to the emotional rhythms of human sleep and wakefulness. Even today, some studies suggest that people sleep slightly less during full moons, a subconscious nod to our ancient relationship with this glowing satellite. So when the tide rises tonight, and you hear the distant lap of waves or sea puddles and the street swells slightly at the curb, know this: you are watching gravity made visible. You are seeing a message from the moon, delivered through water, a whisper that says, I'm still here, still pulling, still dancing with your world. Even as it slips away, the moon remains close. Close enough to shape the oceans, close enough to turn seaweed, close enough to coax fish into shallows, close enough to rock the very water inside you. Because your body, too, is made of tides. And maybe that's why you feel something when you stare up at the full moon. Not just awe, not just wonder, but recognition, like seeing an old friend standing at the edge of a great, dark field, waving, still close, still watching, still pulling, in the still silence of Earth's high deserts, where the sky stretches wide and breathless. Scientists stand at the edge of the known world, not with ships, but with mirrors. Not with maps, but with light. There is a telescope, not unlike the ones that search the stars, but it doesn't look outward in wonder. It gazes at something familiar, something close, something you've known since childhood. The moon. Not to admire it, not to photograph its scars and plains, but to speak to it. With light on its surface, just sitting there in the dust and sunlight, are tiny metal mirrors. They are older than most people alive today, and by hands now long returned to Earth. They are not beautiful, not majestic. They are small, square, functional, and they do only one thing. They reflect. Back in 1969, when Apollo 11 made its cautious descent onto that foreign gray dust, astronauts left behind not just footprints and flags, but one of these reflectors, a box of mirrors, perfectly angled to bounce light back to wherever it came from, not scattered, not diffused, but directly returned, as if the moon itself had blinked. In the years that followed, Apollo 14, Apollo 15, and even the Soviet Lunokhod missions would add more mirrors. And so began a silent conversation between Earth and Moon. It's carried by beams of light so thin they are almost not there. Here's how it works. A laser sharp, green, and impossibly fast is fired from an observatory on Earth. It travels upward through the whisper of atmosphere, through night, through space. It flies the distance between a blue planet and its drifting moon, 250,000 miles, until it touches glass, left by hands in spacesuits, and then it returns. Not all of it, not even most of it. Of the trillions of photons fired, only a few find their way home. Perhaps 1 in 100 million. Sometimes less, and yet it is enough to measure. It's enough to know. It takes light just a little over 2.5 seconds to make the round trip, and each time that measurement is taken, it changes by millimeters, by centimeters, tiny delays, tiny steps backward. That's how we know the moon is leaving. Not by myth, not by guesswork, but by the light that leaves and the light that returns. A beam of clarity in the long, soft dark. This experiment is called lunar laser ranging, and it has been quietly running for decades. A whisper between worlds, carried not by emotion, but by numbers, at the Apache Point Observatory in New Mexico. Where the stars feel closer, scientists have perfected this ritual. Night after night, they fire light at a mirror that floats in silence, 384,400 kilometers away. And the moon responds, not with words, but with patience, with geometry, with truth. The data is clear. Each year, the moon moves away from us by 3.8 centimeters. Year after year, the rhythm holds. You might ask, why does this matter? Why spend decades measuring something so small, so slow? But that's what makes it profound, in a world obsessed with speed. Here is a truth that moves at the pace of erosion, of aging, of change too slow for the human eye. And in that slowness, there is revelation. We learn how planets speak. We learn that the Earth spins more slowly as the moon drifts. We learn how time itself stretches differently because of this quiet pull. We learn that space is not a still place. Even now, as you sit, as you breathe, as you drift toward sleep, this conversation continues. The laser fires. The moon reflects. The numbers change. And a story unfolds, written in milliseconds and meters. The beauty of this is not in spectacle. It is in certainty. There is something comforting about knowing that even the sky can be measured with light, that even vast distances can be touched by a beam and answered by a mirror. That silence can still be conversation. That drifting doesn't mean lost, and there's something else. 2. This system has lasted for more than 50 years. It spans generations. Scientists pass the responsibility from hand to hand, like a lantern in the dark. One team begins, another continues. A third one refines the math, and in doing so, we've created a record, not just of the moon's distance, but of our attention. We've watched it, and it has responded. Over time, precision has grown. We can now tell if the moon has shifted by as little as a few millimeters. We know how its orbit wobbles. We know how its speed changes during eclipses and alignments. We know that the moon is not just an old companion. It is an active participant in the story of Earth. Its motion affects our tides, our weather, even the length of our days, all because we bounced a little light off a little mirror left behind in the dust. That is the miracle of science. It doesn't always need spectacle. It doesn't demand noise. Sometimes it just needs someone to point a light at the sky and listen for what comes back. Sometimes it needs nothing more than a question, a laser, the patience to wait for an answer. And so the experiment continues tonight. Somewhere in a desert, someone leans over a console. They check the coordinates. They align the scope. They fire the beam. The moon, half full and softly glowing, feels the touch of light on its mirrored skin. And somewhere, a photon returns home. The numbers are small, 3.8 centimeters a year. That's how far the moon slips away from Earth every 12 months. It's a distance smaller than the width of a child's palm. A drift that seems laughably insignificant when measured by ordinary human eyes. But the Earth notices, not because it's dramatic, not because the sky darkens or the oceans rise overnight, but because all things, even celestial bodies, change when something they love moves away. You won't feel it under your feet. You won't see the moon shrink in the sky. There's no farewell letter, no sudden leap. It's just that constant, faithful distance, growing by the width of a thumb each and every year. Yet that tiny movement tells a bigger story. It is not an escape, not a betrayal, not a fall. It's a gentle, gravitational consequence of a long shared relationship between two celestial bodies who've danced together for over 5 billion years. You see, Earth spins. It has always spun. When it was young, it spun fast. A day was only 5 hours long. The sun crossed the sky like a spark, and the moon, it circled much closer, large in the sky, pulling strongly on the oceans, whispering to Earth with tidal hands. But as the moon tugged, the Earth responded, and the physics of that pull created friction, not the kind that burns, but the kind that slows. Little by little, the Earth's rotation began to stretch out, from 5 hours to 6 to 12 to 24. And as Earth's spin slowed down, the moon was flung gently, steadily, further out. It's a conservation of energy written not in flames, but in gravity's quiet bookkeeping. Energy lost by the spinning Earth is gained by the orbiting moon. That's the exchange. That's the deal. And so, the moon climbs higher in the sky each year. It doesn't mean to leave, but it must honor the math. If you were to freeze time and place a long ruler from the moon to Earth, you would see a line that stretches ever so slightly more with each passing century. In a human life, that difference is imperceptible. Even over 1,000 years, it amounts to little more than a football field's length. But over geologic time, it is profound. 500 million years ago, the moon was so close that it dominated the night sky, perhaps appearing 3 or 4 times larger than it does now. Imagine it, a sky not ruled by stars, but by a silver giant, hovering low and bright. Its craters sharp, its pull strong. Back then, the tides were fierce. Waters surged across continents, shorelines bent and twisted with lunar gravity. And the Earth, it spun like a child on a carousel days, racing past in only 18 hours. Coral fossils tell this story, not in words, but in rings. Ancient coral builds its skeleton in layers, like tree trunks. And by counting those growth lines, scientists discovered something strange. A single year once had more than 400 days. Why? Because the days were shorter. The Earth spun faster, and the moon hadn't yet drifted so far. It's strange, isn't it? You can read the moon's departure in the skeleton of a prehistoric sea creature. that the quiet slip of one body from another echoes in the reefs, the rocks, the fossils of a time before memory. This drift is not something to fear. It is not sudden, it is not doom. It is the natural pacing of a planetary relationship adjusting to its own aging, like two dancers, once close, who now move with more space between them, but still in perfect rhythm. There is elegance in that. There is comfort in knowing that even the moon's departure is a process so slow, tender, that the only beings who can detect it are those who listen for it with lasers, mirrors, and patient eyes. Still, some wonder, what will happen if this drift continues? Will the moon one day vanish from the sky? Will it leave entirely? Will Earth be alone? The answer is why yes, but not for billions of years, and not in a way you would expect. Eventually, as the Earth's rotation continues to slow and the moon continues to move away, they will reach a balance, a moment when the Earth's day is exactly as long as the moon's orbit, a tidal lock, a final embrace. At that point, the same side of the Earth will always face the moon, just as the moon already shows only one face to Earth, two bodies locked in gaze, motionless, but orbiting together like twin coins floating in silence. And when that happens, the moon's drift will stop. It will settle into its final orbit, and Earth's days will stretch to 47 hours. Sunrises will be slower. Sleep may grow longer. And humanity, if we're still here, will live in a slower rhythm. Of course, long before that balance is achieved, our sun will change. It will expand. It will swallow Mercury, then Venus, and perhaps even Earth. The moon's journey, beautiful as it is, will be just one chapter in a much larger cosmic story. But for now, you still have it. Each night, you can look up and see a silver circle, gliding slow and bright, shining softly over rooftops and oceans, still close enough to tug the tides, still steady enough to keep time with our days. And though it moves away, you are not abandoned. The moon leaves traces in your world, not just in gravity, but in poems, in lullabies, the way children draw night skies with a pale crescent above the trees. It lives in your language. It lives in your tides. It lives in your dreams. So let it drift. Let it follow its ancient path. Let it obey the laws that shaped it in fire and guide it now in silence. Because in every inch it moves, there is a story of motion, of balance, of love that doesn't cling, but orbits. And tonight, as you lie still beneath the sky, you are part of that story, too. The clock is not broken, but it is not fixed either. Time is not the steady tick we imagine. It's not something wound by human hands and measured by gears. The true clock of the Earth does not hang on a wall. It spans beneath your feet, and slowly, very slowly, it's losing speed. Every year, your planet spins just a tiny bit slower. It's not enough to notice, not enough to change your morning commute or make the nightfall any differently. But deep in the record of the Earth, there are signs, clues that tell us our world used to move faster, not in politics or in culture, but in the actual rotation of the sphere beneath your shoes. Each day is just a little longer than the one before it. Milliseconds, the kind of time that doesn't show up on wristwatches, but builds silently over centuries. You see, when the moon pulls on the oceans, it doesn't just raise tides, it creates friction. The water doesn't leap instantly from one shore to another. It lags behind. In that lag, a delay written in billions of tons of liquid acts like a brake. Earth spins. The ocean resists. The result is drag. You can't feel it, but Earth's spin is being slowed by its own tides. Tides created by its closest companion. The moon causes the ocean to rise, and the ocean causes the Earth to hesitate. It's a slow conversation, a gravitational argument, one with no anger, only inevitability. Over millions of years, this drag has added up. In the early days of the planet, when Earth was new and hot, it spun so fast that a full day lasted only 5 hours. 5 hours between sunrise and sunrise. The sky would have been a blur. The sun crossing overhead like a spark on a fuse. Shadows chasing each other too quickly to settle. A world spinning and fast forward. And as time passed, the earth slowed 10 hours. 12, 18, 20-4. Not from exhaustion, but from balance. From the steady resistance of its own seas and the gentle push of its moon. Now, each day is about 24 hours. But that number is not fixed. Each year, Earth's rotation slows by about 1.7 milliseconds. Not much, barely the blink of an eye. But it accumulates. Eventually, the difference is large enough that calendars must be adjusted. That's why we have leap seconds, a little correction in our human-made timekeeping to account for a planet that refuses to spin at exactly the same speed forever. It's strange, isn't it? Think of time as something elastic, to realize that the concept of a day is not universal. It's a local truth, a number based on Earth's own behavior. And Earth, like everything in the cosmos, changes. The slowing of the planet means that days will continue to lengthen long after your lifetime and the lifetimes of your children's children. The day will stretch past 25 hours, then 26, then more. It won't happen quickly. Millions of years must pass. Right. The direction is clear. The Earth is slowing down, not dying, just settling like an old machine that still runs, but with a quieter rhythm. And the moon is the reason. The same celestial body that pulls your tides, brightens your night sky, is responsible for the stretch of your days. It's a strange kind of love story. One body pulling on another, changing it not through violence, but through quiet influence. There's something comforting in that, to know that time is shaped not just by decay, but by relationship. The Earth and Moon have been partners for billions of years, and in that time, they've changed each other. The Moon's orbit grows, the Earth's spin slows, and together they move toward a future where their rhythms match. That is where all of this is going. Eventually, billions of years from now, Earth will reach a point where it always shows the same face to the Moon, just like the Moon already does. This is called tidal locking, a kind of balance achieved through endless patience. At that point, a single day on Earth will last as long as a lunar orbit, about 47 current Earth days. That means sunrise and sunset will take weeks to complete. Night and day will become long, stretches of light and shadow, like slow breathing. Imagine the rhythms of life in that kind of world. A single workday would be 2 weeks of sunlight. A school year might be just one full rotation. It's poetic to imagine, even if it's not a future we will see in that distant world. The moon will hover in the same place in the sky, never rising or setting, just a constant companion in one direction, and Earth will return the favor. One face always turned to the moon, as if saying, "I remember you." But we are not there yet. Today, the moon still rises, still sets, still climbs the sky and arcs across rooftops and ocean waves, and Earth still spins in 24 hours, a rhythm you can count on. For now, but underneath that constancy is a change, a day that is not the same as yesterday, a spin that is just slightly slower, a world that is aging in the gentlest way. You feel it in nothing, but it's there. The Earth is breathing deeper, turning slower, sleeping a little longer with each passing age. So tonight, when you close your eyes, know that the day you just lived was longer than the day before, and tomorrow's will be longer still. Not by much, not by enough to see, but enough to remind you that nothing stays still. It's not even time. And in that slowing span, there's peace, because it means you are part of a planet that is still moving, still adjusting, still learning how to dance with its partner in the sky. It means you live in a universe where time flows, not in minutes, but in orbits, in tides, and gravitational whispers, a universe where even the ticking of the cosmic clock is softened by love. Let it slow. Let the day stretch. Let the moon drift. You are part of this rhythm, and tonight you are right on time. There are clocks that don't tick, they don't glow, don't chime, don't count minutes in neon digits or whisper seconds in a mechanical heart. Some clocks grow quietly, underwater, in silence, and they remember time in ways your wrist never will. You see, corals do not forget. They are creatures, yes, living animals, but they build. Layer upon layer, they form calcium homes from the minerals in the sea, and with each layer, they record a rhythm. Not a thought or memory, but of light and motion. Corals grow in pulses. It's a subtle internal calendar tied to the sunlight, the warmth, the sway of the tide in their bones, their skeletal rings. They keep track of days and seasons the way trees do, only slower and saltier. They do not write diaries. They do not observe, but their structure speaks if you know how to listen, long after they've died. Fossilized coral colonies can still whisper what the world once felt like, and what it once moved like, because these ancient reef builders, planted deep in prehistoric oceans, hold a record not just of temperature or salinity or sunlight, but of time itself. When scientists examined the growth rings of corals that lived 400 million years ago, they found something strange. Each ring was like a heartbeat, a pulse for each day. And when they counted how many pulses filled a year, the number was not 365. It was more than 400, which means 400 million years ago, a year still lasted the same length, measured in how long it takes Earth to orbit the sun. But the days were shorter, because there were more of them the same year, which means Earth was spinning faster. The moon was closer. The tides were tighter. The whole Earth rotated like a toy still fresh from the box, wound up and humming with energy. Imagine it, a planet turning more quickly, sunrises that came earlier, nights that didn't linger, waves that curled higher, pulled harder by a nearer moon. It wasn't science fiction. It was science etched in ancient coral with the patience of a billion heartbeats. These coral clocks give us a gift, a glimpse at the invisible, because they do not exaggerate, they do not forget, and they cannot lie. They are geologic truth in the shape of a reef. It is humbling to think that a simple marine creature, a colony no bigger than your outstretched hand, can reveal something about the Earth's ancient rhythm that no human could ever witness. Corals are not storytellers, but they are witnesses. They were there when the moon was closer. They were there when Earth spun fast and young, and they left behind their breath marks, calcium notes in a watery song that now plays for scientists millions of years later. What's strange is how corals are so unremarkable to the casual eye. They look like rocks, static, UNMOVNG, but inside they are alive, tiny animals called polyps building empires, micrometer by micrometer. They are creatures that make stone, and in that stone they record time. Each coral ring is like a line of poetry. It's written in a language older than language itself, and the poem they write is about the slowing Earth, the lengthening day, the moon's gentle drift. There is no urgency in their message. It's quiet persistence, like all the best things in nature. Corals don't shout, they accumulate, and when coral colonies die after decades, centuries, they leave behind a fossil with rings like pages in a book that no one meant to write until someone opens it and listens in their depths. Scientists discovered that the Earth's rotation has been slowing for hundreds of millions of years, and that change wasn't guessed or assumed. It was measured. A coral. Imagine the patience required to listen to something so slow, to study a fossilized reef and count microscopic ridges to find the number of sunrises in a year that passed. before the dinosaurs existed. That's what these researchers did. And the story the coral told was elegant. More days, shorter days, a younger Earth spinning fast, okay? A moon still tightly held in orbit. The same moon you see now, but not in the same place, over time, okay? The moon has drifted away, and Earth has slowed, and the rhythm has changed. All of it tracked by something growing in silence beneath ancient seas. That's the beauty of natural archives. Ice holds memory in its bubbles. Trees hold memory in their rings. And coral holds time in stone whispers. You may never touch coral. You may never swim among reefs or dive into warm salt water where colonies bloom like frozen fireworks. But even on land, miles from the ocean, you live on a planet whose rotation is defined by what corals remember, because their truth tells us who we are. Not metaphorically, but physically. You wake each day in a lengthening loop of time, made measurable by skeletons of sea creatures you've never met. There's a strange intimacy in that. Your morning alarm clock is tuned to a rhythm first noticed by fossilized coral. The earth turns, the moon drifts, the day lengthens, and coral remembers. It is the softest kind of science, the science of quiet things that measure loud truths. So if you ever find yourself by the edge of the sea, and you see a piece of coral washed ashore like broken lace, hold it gently. You're holding a piece of the planet's memory, a page from the book of time, a clock that never needed hands to count what mattered, a reminder that you, spinning with this world on a slowing axis, are part of a very old, very quiet rhythm, one that doesn't forget. And tonight, as the world turns again, you sleep in that rhythm, your breath keeping time with ancient tides and coral dreams. There's a number buried in physics. It's not loud, it's not easy to picture, but it has power. It's called escape velocity, a boundary, a quiet threshold between belonging and drifting into forever. For Earth, that number is around 11.2 kilometers per second. If you want to leave, not just fly, not just orbit, but leave and never come back, that's how fast you must go. Everything held by gravity, everything tethered to this blue planet, must beat that number to be free. It applies to rockets, to stones thrown from cliffs, to drifting satellites, and very slowly, to moons. The moon isn't trying to escape, not like a ship with flame and fuel launching in a single spectacular moment. No, the moon is moving in quiet rebellion, a soft outward slide, a silent drift, each year just a few centimeters farther away. Not even the width of a child's hand, but add that over time, over eons, and the distance adds up like a whisper you barely hear until it's gone. Why does it drift? 'Cause of tides. The moon pulls at Earth's oceans, and Earth resists, not out of anger, but inertia. The oceans bulge. They drag. They pull slightly ahead of the moon's orbit, and in return, Earth transfers energy to the moon. It's a gravitational nudge, repeated endlessly, like a cosmic swing being pushed ever so gently. And what happens when something receives energy again and again? It climbs higher, faster, farther. The moon moves outward, carried by invisible hands, 1 centimeter at a time. Right now, it's still held tightly by Earth's embrace, bound in orbit, locked in an ancient dance. But we know the math. We know how energy works. We know how orbits stretch and decay. And if given enough time, enough millions, billions of years, the moon could one day drift far enough to pass that invisible line, the escape velocity. And if it does, it would not crash. It would not burn. It would simply keep going, leaving the Earth behind like a boat losing sight of shore. That's the cold truth of celestial mechanics. Nothing is truly permanent. Even the moon, that steadfast silver eye, has the potential to say goodbye, not in your lifetime, not in 1,000, but one day, if the drift continues, if the energy flows unbroken, if no great disaster intervenes, it could leave. What would that mean? What would happen if the moon broke free? Let's walk into that possibility slowly, softly, as if tracing footsteps in dust that hasn't been disturbed for a billion years. First, Earth would change its rhythm right now. The moon tugs at the oceans. It raises tides. It balances Earth's tilt. It acts like a gyroscope, keeping our seasons gentle, our climate steady. Without it, the planet would wobble like a spinning top slowing down on a table. The seasons could become chaotic, unpredictable, a summer that never ends, a winter that arrives too soon. Tides would weaken, but not disappear. The sun also pulls at our oceans, but its tides are smaller, quieter, less reliable. The moon's departure would turn our beaches into quieter places. No more regular rise and fall, no more dependable rhythm in the sea's breath. The nights would grow darker. Right now, the full moon lights up the world, enough to cast shadows, enough to see your hand in the dark. Without it, the stars would dominate. The night sky would return to something ancient, brighter, with starlight, let L-O-N-E-L-I-E-R. And the stories would change. For thousands of years, humans have woven myths around the moon. It's been a symbol of love, of madness, of time. Its cycles became calendars. Its glow inspired art, poetry, long walks under silver skies. What happens to a species when the thing they've loved the longest disappears? Will we tell stories about what we lost? Would children ask, what was the moon like? Would we try to build a new one, some artificial satellite placed in orbit to mimic the tides, to cast light over oceans and shadowed cities? Or would we simply adapt? Let the tides shrink, let the seasons tilt, let the myths fade, perhaps. But this is not something you'll need to witness. Not now, not soon. The moon is still close, close enough to pull, to shine, to hold. It is not running. It is not rebelling. It is just moving according to rules older than memory. And in that motion, there is a lesson about love that doesn't cling, a lesson about gravity that gives space. The earth holds the moon, but not so tightly that it cannot drift. The moon circles Earth, but not so rigidly that it forgets how to move outward. It's a relationship written in silence and orbit, in pull and permission. Even now, as the moon drifts away, it still circles, still watches, and Earth, slowing ever so slightly, still responds. That's the strange part. As the moon moves away, Earth's days grow longer, milliseconds at a time. It's not just that the moon is leaving, it's that we are changing. As a result, one cannot move without affecting the other. So you sleep tonight, beneath the sky that is still faithful. The moon is still there, still glowing, still pulling the tides, still making nights into something more than dark. But you know, now, that it is not still, that even loyalty drifts, that even companionship evolves. And one day, far beyond the reach of calendars, the moon may slip beyond escape velocity, and it won't be a betrayal. It won't be a rupture. It will be the natural outcome of an ancient dance reaching its farthest step. Earth and moon, partners for now, dancers for a time, bound not by chains, but by orbits and tides and energy exchanged in silence. Tonight, the moon is still with you. So go outside, look up, feel the pull of something ancient and gently drifting, and know that for now, you are still held in the quiet embrace of a moon that hasn't quite said goodbye. Imagine a night sky with no familiar glow, no silver disk rising behind rooftops, no tides whispering toward shore, no soft reminder that something is always circling you in quiet. This chapter isn't about fantasy. It's about possibility. It's a lullaby woven from science. A simple question, really. What would happen if the moon disappeared? The answer, like the sky, is layered and wide. To understand what would be lost, you must begin with what the moon gives. It gives rhythm. Right now, Earth is a planet in balance. Tides breathe in and out, not just because of wind or weather, but because of the moon's gravity. The moon reaches for the oceans, and they rise in gentle answer. Twice a day, every day, everywhere. These tidal flows do more than move water. They shape coastlines. They stir nutrients. They influence ocean currents. Some marine creatures, from coral to crabs, live by the pulse of tides. Without the moon, these pulses would falter. The sun still tugs on the sea. Its tides are smaller, slower, more shallow. But without the moon, the rhythm would lose its anchor. The oceans would quiet, too quiet, and ecosystems would forget how to count time. Plants that bloom by moonlight, timed to a lunar calendar older than writing, would bloom confused. Creatures that make by tides would lose the rhythm that tells them when to begin. The moon gives time. Long before watches, before calendars, people looked up to mark the passing days. A crescent meant beginnings. A full moon meant fullness. A dark sky meant rest. Entire cultures shaped their lives around the moon's monthly rhythm. Lunar calendars, festivals, harvests, even words, month, derived from moon th, whisper its presence. Without it, human timekeeping would feel unmoored, like a song without a beat. But tides in time aren't all. The moon gives tilt. Earth doesn't spin perfectly upright. It leans just a little, about 23.5 degrees off center. This tilt gives us seasons: spring, summer, autumn, winter, all because Earth presents different faces to the sun throughout the year. But here's the secret. The moon holds that tilt steady, like a weight on a spinning top. It stabilizes Earth's wobble. Without the moon's gravitational embrace, Earth would begin to lurch. Over thousands of years, its axis might tilt wildly, maybe 45 degrees, maybe more. Imagine Antarctica bathed in tropical light. Imagine deserts plunged into darkness, not overnight, but over centuries, climate and anchored. Ice ages without warning, monsoons that never stop, and species, including us, struggling to keep pace with a sky that forgets how to repeat itself. The moon gives balance, even emotionally. The moon gives something few have words for, a sense of presence. To walk outside and see it is to feel less alone. It is ancient, unchanging in its pace, soft in its authority. Poets have written to it. Lovers have sworn by it. Astronauts have touched it. Without it, the sky would feel emptier, colder, still beautiful, yes, but missing something familiar, something reflective, because that's what the moon is. A mirror. It reflects sunlight, but it also reflects us. When we look up, we see the past, our own, and the planet's. Now, picture a planet where the moon is gone. The tides fall to silence. The tilt begins to wander. The days stretch imperceptibly longer. The nights become permanently dim. What else happens? A satellite shift, some orbiting. Machines use the moon as a reference point. Navigators in space use this position to plot their courses. Without it, the math changes. The maps change. The whole solar system's clock ticks differently. Cultural memory fades. Folklore would lose its center, from werewolves to fertility goddesses. The moon has always represented cycles, mystery, change. Take it away, and something in our collective imagination goes dim. Art might lose a favorite subject. Language might lose its oldest metaphor for love, longing, madness, and return. Now, imagine this, not as fantasy, but as something possible. The moon is drifting. It won't disappear tomorrow. But in billions of years, if the drift continues, it may break free. And when it does, it won't fall. It won't explode. It will glide silently into the black dot. No goodbye. No crater. Just distance. And Earth will be different. Not broken, but changed. It may still have life. Still spin. still glow with city lights and lightning storms. But something will always feel missing. A companion, a stabilizer, a soft reminder that something is always circling you. What would we do in such a future? Would we build an artificial moon? One that rises on command, glows with LEDs, and moves in programmable arcs? Would we send probes to chase the drifting moon, to try and tether it with science? Or would we simply adjust, learn to live without it? It's impossible to say, because right now, the moon is still here. And maybe that's the most important part. To know it is drifting and still here. To understand that the things we love are always slowly changing. That beauty doesn't have to last forever to be meaningful. That presence, even one measured in inches per year, is still a gift. So tonight, when you see the moon, whether full or slivered, it's clouded or clear, pause, look, and remember, it is leaving you as gently as anything ever could. Not because it wants to, but because it must. Because that's what the laws of the universe do. They stretch, they shift, they evolve, and they carry even moons into the distance. But not yet. Tonight, it's still with you, still holding your tides, still cradling your tilt, still being the mirror in your sky. Let that be enough. Let it lull you. Let it remind you that even departures can be peaceful, even drift can be soft, even goodbye can take a billion years. There's a dance playing out above you. It's quiet, deliberate, measured in millions of years, not minutes. The earth turns slowly, and the moon drifts silently, bound together by gravity. They are locked in an ancient rhythm, a celestial waltz, neither one ever meant to start, and yet neither can stop. This is not the kind of dance you see. You feel it in the shifting tides, in the slowing spin of the earth, in the endless pool of time. And it has a future, one that plays out not in centuries, but in eons. To imagine it, you must stretch your mind past calendars and clocks, past lifetimes, past even the rise and fall of civilizations, because this is the story of cosmic patience. Right now, if you read this, the moon is slowly escaping Earth's embrace, not out of defiance, not in anger, but because of the same gravity that once brought them together. Each year, the moon drifts about 3.8 centimeters farther away. Just a little more space, a few more inches of silence, and Earth responds as the moon slips away. Our planet's rotation slows, not by much, just a couple of milliseconds every century. But slowly, our days are growing longer. Once, hundreds of millions of years ago, a day on Earth was only 18 hours long. Now it's 2 for some day dash far. Far in the future, it may be 30 or 36 or longer. And with every lengthening day, with every inch of drift, the moon and Earth grow closer to a strange kind of perfection. They are on a path toward what scientists call tidal locking. You see, the moon is already locked to us. That's why we only ever see one side of it. It rotates on its axis at the same rate it orbits Earth. So its far side, what some call the dark side, remains hidden from our gaze. But Earth is not yet locked to the moon. We spin faster than it orbits. Someday, that will change. In the far future, billions of years from now, the Earth's rotation may slow to the point where one side always faces the moon. Two bodies, locked in gaze, never blinking, never looking away. Imagine that world. Half of Earth would always see the moon, a massive, motionless companion hanging in the sky, always full, always there. The other half would never see it. An eternal night without moonlight. A sky where the stars speak freely, without interruption. It would be a strange new balance. Not bad, just different. Of course, this future depends on the long survival of both Earth and Moon. And the solar system is full of surprises. Asteroids, solar flares, the swelling of the sun itself. One day in the distant future, our sun will expand into a red giant. Its outer edges may reach Earth's orbit, planets may burn or be swallowed, and the moon, it might be drawn back inward by the swollen sun's gravity, or ejected completely from orbit, or torn apart by tidal forces into a ring of debris. No one knows for sure, because even with all our telescopes, all our equations, can't see that far ahead with certainty. But we can imagine, and that imagining too is part of the dance. There are other possibilities before Earth and Moon become tidally locked, before the sun expands, before anything cosmic disrupts the rhythm. We, the humans, watching from below, may interfere. What if, in some distant future, humanity builds engines to adjust the moon's orbit? What if we slow its drift to preserve the tides we know? What if we colonize the moon, not just visit, but build, live, transform? Would we want to tether it closer, prevent its escape, or let it go and follow it outward as we chase the stars? There's poetry in both visions. The moon held close like an ancient talisman, or the moon drifting away, free and luminous. Whatever happens, this isn't a breakup. It's a slow rebalancing, because the Earth and Moon don't hate each other. They're not fighting. They are dancing to the music of physics. Every orbit is a step. Every tide is a breath. Every drift is a pause in a choreography, billions of years long. And you, the human looking up, you are not separate from this. The same gravity that binds the moon to Earth binds your feet to the ground. The same forces shaping planetary span shape your days and nights. You are part of this dance, even if you never feel it. Maybe that's what the moon has always been, a reminder that stillness is often an illusion, that even what seems permanent is always moving. So the future of the Earth-Moon dance isn't a tragedy. It's a long, slow unfolding, a partnership that grows, shifts, adjusts, just like all relationships do. One day, Earth will spin differently. Its skies will look new. Its days will stretch like long sighs. But tonight, and for millions of nights to come, the moon is still out there, still circling, still reflecting sunlight across oceans and windows, still pulling at the sea, and at you, still dancing. You don't need to understand orbital mechanics to feel its presence. You only need to look up. So go ahead, even if the sky is cloudy, even if you're indoors. Close your eyes. Picture that pale, cratered face gliding silently through the dark. Not fleeing, just moving with you, always, always. The moon is not alone in the vast family of our solar system. Moons are plentiful, far more numerous than planets themselves. While Earth has just one companion, Jupiter has dozens. Terns, moons stretch across the cold shadows of its rings. Even distant Uranus and Neptune are surrounded by icy satellites. Each moon tells a story. Some echo the silence of lifeless stone, others hum with quiet possibility. And as we send telescopes and probes to listen more closely, we realize our moon may be only the beginning of the tale. Start with Jupiter, the giant among giants. Orbiting this gas titan is a miniature solar system of its own, nearly 100 moons, large and small, spinning in elegant chaos. Among them is Europa, a smooth, bright orb of ice. At first glance, Europa seems frozen and still, but beneath its crust, beneath, the fractures and lines etched like old scars lies in ocean. A hidden sea, perhaps twice the size of all Earth's oceans combined, kept warm, not by sunlight, but by the subtle heat of tidal flexing. Imagine that, a moon with an ocean, warmed from within. No wind, no surface rivers, just darkness, salt water, and Mabel life. Scientists wonder, could there be creatures below Europa's crest? Its blind swimmers drifting through black water, its microbes clinging to hydrothermal vents. We don't know, not yet, but the possibility lingers like breath on glass. Then turn your gaze to Ganymede, larger than Mercury. This moon is the biggest in the solar system. It even has its own magnetic field, something no other moon can claim. Ganymede, too, may hide an ocean beneath its surface. But it's deeper, colder, more mysterious. Some models suggest layers of salt water, ice stacked like a cosmic parfait. No sunlight reaches those depths. But life, we've learned, does not always need the sun. It only needs time and warmth. In chemistry, Callisto, another of Jupiter's children, is pockmarked like a forgotten battlefield. Craters, layer upon craters, each one a memory of impact. Yet even this ancient moon may harbor subsurface water. It is quiet, cold, undisturbed, but not without potential. The outer solar system is full of such quiet places. Worlds that do not shine, that do not sing, but under their stillness may lurk something utterly alive. Now drift toward Saturn. There you find Enceladus, a small, bright moon that sparkles with secrets. In 2005, a spacecraft named Cassini passed close by. What it found was astonishing. Geysers of water shooting into space from the South Pole. Jets of vapor and ice, rich with organic molecules, sprayed from cracks in the icy crust. Imagine standing there on the frozen surface of a distant moon, watching water erupt into space like breath. What lies beneath those cracks? A warm ocean, a hidden sea, a world within a world. NASA now considers Enceladus one of the most promising places to search for life beyond Earth. Not because it looks like Earth, but because it dials in. Titan, Saturn's largest moon, is wrapped in a thick orange haze. It's the only moon in the solar system with a dense atmosphere. Its skies rain methane. Its rivers and lakes are made not of water, but of liquid hydrocarbons. It is alien, strange, and beautiful. On Titan, the temperature is cold enough to freeze your breath in midair. Yet it has weather, seasons, wind-sculpted dunes, lakes that lap against rocky shores. No one expects life here to be like ours. If it exists at all, it may swim in methane, metabolize gases we'd consider toxic, and breathe in ways we can't yet imagine. But again, the question repeats. What if, even farther out, Neptune's moon Triton orbits backward against the direction of the planet's spin? This strange retrograde path suggests Triton was once a wandering object, captured by Neptune's gravity. It has geysers, too, and a surface, shaped by forces we don't fully understand. A frozen world, possibly active, dancing to a tune it didn't begin with. Why does this matter? Because when we look at these moons, distant, often ignored, we begin to understand something quietly profound. Earth is not unique in its potential. The ingredients for life, liquid water, heat, organic molecules exist in many places. They just exist differently. Life may not thrive under blue skies and golden suns. It may pulse beneath layers of ice in endless dark oceans. It may flow with methane, bloom in volcanic snow, whisper in frozen clouds. We used to think that planets were the only homes for life, that moons were just decorations, rocky ornaments for larger bodies. But moons, it turns out, may be the true havens, the hidden sanctuaries, quiet hosts. They don't seek attention, They don't boast. They don't shine on their own, but they hold secrets. And maybe, somewhere in those frozen shells and geysers, one of those secrets is life. Not loud, not advanced, but life trembling softly in a tide pool beneath the crust. And here's the strangest thought of all. What if our own moon once held more than we knew? Long ago, its surface boiled with molten rock. It may have had a thin atmosphere, if only for a moment. It may have vented gases, carried heat, and glowed in ways we'll never fully grasp. Its time has passed. It is dry now, silent, steady. But it may once have whispered, too. So when you look up at the moon hour moon, remember, it is part of a family. chorus of quiet companions orbiting distant giants, each one turning, drifting, dreaming its own story. Some are still, some sink in steam, some we haven't even found yet, but all remind us of the same thing. We are not the center, not of the universe, not of the solar system, not even of what it means to be alive. We are listeners, observers, and maybe, just maybe one day, explorers, not to conquer, not to escape, but to understand, because the moons out there, in their silence and strangeness, might not just be other worlds. They might be mirrors, reflecting back to us what we've yet to learn about life, time, and the extraordinary quiet of the cosmos. Before science measured its distance, before lasers traced its drift, before astronauts left bootprints in its dust, the moon was a mirror for the soul. It was the first light we noticed after sunset. It's the quiet companion to our fears and wishes. Long before we knew what it was, we knew what it meant. And meaning, like gravity, holds tight. Across cultures, across time, every civilization that looked skyward wove stories from the moon's light to the ancient Greeks. The moon was Selene, a radiant goddess in a silver chariot, driving across the night sky. Later, she became Artemis, the huntress sister of Apollo, free, wild, and deeply tied to tides and tied to the Romans. She was Luna, a divine force responsible for madness, hence the word lunatic. In India, the moon is Chandra, a deity of coolness and calm. He rides a chariot drawn by antelope, a symbol of rejuvenation and love. In China, the moon hosts the legend of change, a goddess who lives alone in its vast emptiness, having floated there after drinking an elixir of immortality once a year during the Midotone festival. Lanterns float skyward in her honor, a quiet reunion between Earth and its loneliest deity. And among the Aztecs, the moon bore the scar of a divine battle. According to their myth, the gods threw a rabbit at the moon's face to dull its brightness. And even today, some cultures say you can still see the rabbit's shape in the lunar surface. Not a man, not a crater, but a memory in fur. The moon. In human emotion, the moon became more than just a character. It became a stage for the theater of the heart. It stood for longing, for distance, for promises kept from afar. It watched over soldiers and lovers. It bore witness to the nights of farmers and poets. It became the symbol of things just out of reach. In Japanese haiku, the moon was often a season word, a way to signal autumn without ever saying autumn. In Islam, the crescent moon became a sacred symbol, marking time for fasting, prayer, and community. In early Christianity, it was sometimes seen as the mirror to Mary's gentleness, a reflection of heavenly purity, soft and nurturing in the dark. Even in modern art and literature, the moon keeps its pull. Virginia Woolf once wrote of being in the moon's lap. Sylvia Plath described it as a face in its own right. And Shakespeare, he gave it lines. "Oh, swear not by the moon, the inconstant moon," warned Juliet, knowing even love should not be tethered to something that waxes and wanes. Lunacy and light. The moon wasn't always kind in myth. Its phases seemed to trigger madness. Werewolves howled beneath its fullness. Dreams turned restless. Men paced the floor. Women wept into handkerchiefs. Doctors once believed lunar cycles caused swelling in the brain, hence lunacy. Even tides in the womb, it was thought, were drawn by the moon's moods. Science has since softened those claims, but something ancient remains in the way we feel when the moon is large and low, rising orange on the horizon like a coin too big for any purse. The moon in calendar and clock long before quartz watches or atomic time. Humans measured life in moons. A month, after all, is a month, the time between one new moon and the next. Ancients, Babylonians, Egyptians, and Mayans all use lunar calendars to plant crops, predict floods, and celebrate holy days. Even now, okay? Many holidays remain lunatide. Ramadan begins with the sighting of the crescent. Easter arrives on the first Sunday after the first full moon following the spring equinox. It's Passover, Diwali, Chinese New Year, all dance to the moon's rhythm. It is as if, in the absence of a heartbeat, humanity borrowed the pulse of the sky. A celestial metronome, the moon, taught us how to wait. Its phases knew. Crescent, half full, taught generations that everything comes in cycles, that darkness passes, that light returns, that change is not loss, but renewal. You could measure sorrow by a waning moon, and mark healing by a waxing one. Even now, people sit by windows and say things like, "The moon is almost full tonight," as if noting a tide in their own chest. The moon as mirror, perhaps. What the moon has always done best is reflect, not just sunlight, but us, our emotions, our superstitions, our hope, our desire for rhythm, our need for science. The moon became whatever we needed it to be: a guardian, a warning, a secret, a friend. It was a diary in the sky, always visible, never reading back. When we felt alone, we looked up, and there it was, silent, silver, knowing nothing but seeing everything. And then we touched it, for all its myths and meanings, for all its poems and prayers. The moon remained untouchable until 1969, when Neil Armstrong stepped down from the lunar lander. He didn't just place a foot on rock. He landed on centuries of dreams. Science collided with symbolism. Boot prints smudged ancient metaphors, and yet something of the mystery remained. Even now, after flags and footprints, the moon does not feel owned. It is not conquered. It is not ours. It drifts away slowly, as if reminding us, you were only visiting in memory and imagination. Today, children still point to it. Lovers still kiss beneath it. Writers still pause to describe its shape. Round as a coin, thin as a fingernail, broken, hiding, okay? Watching. The moon keeps showing up in lullabies, fairy tales, songs with soft chords. It becomes a mother's face, a wolf's god, dream's destination. It becomes whatever you need when the lights go out. A soft goodbye. And so while scientists measure the moon's distance with lasers and math, we still measure it with memory, with myth, with metaphor. It may be drifting away, but we carry it with us in culture, in language, in love, like an old friend we still think of often, even if we haven't spoken in years. The moon, it watched your ancestors plant their fields. It listened to their stories. It whispered back nothing, and yet it said everything. And tonight, wherever you are, if you look up, it's still there, watching, changing, moving away, but never leaving. We know now the moon is leaving, not in leaps, not in loudness, but gently, like a tide retreating with the evening. And though it takes generations to notice, a question begins to stir in the quiet corners of science. Can we catch it? A mirror? In the dust, there's a mirror on the moon. Not figurative, not poetic. It's a real, physical object left behind by Apollo 11 in 1969. ARETROREFLECTOR. It has no wires, no power, just an array of prisms designed to bounce back lasers shot from Earth every day. Scientists aim a beam of light at that mirror. They measure how long the light takes to return. What they've found over decades of laser pulses and precise calculations is that the moon is drifting away from Earth at a rate of about 3.8 centimeters per year, about the width of a fingernail. Unremarkable in a week, but undeniable across eons. And that, brings us back to the question: if the moon is drifting, can we hold on to it? The science of tethering what can't be tied. Let's say you wanted to stop the moon, to freeze its path, to pin it into the sky like a button on a cosmic shirt. How would you do it? Could you fire rockets into the moon's surface just enough to slow its escape? No. The energy required is beyond comprehension. Could you build a tether, an invisible leash from Earth to Moon? Even the strongest known materials would snap under the strain. There is no rope that long, no bridge that patient. Could you move the Earth instead? Shift our planet to match the moon's drift? Yeah. No mass inertia and common sense all conspire to keep Earth where it is. And even if you could move it, you'd move the oceans, the seasons, the sky itself. The cure would undo the patient. The truth, you can't catch a tad. That is the quiet truth of this chapter. There is no way, no physical intervention, no technological miracle, no scientific sleight of hand that can stop the moon's slow farewell. This is not a failure. It is simply physics. But perhaps we can follow what we can do is keep reaching. Even if we cannot halt its drift, we can continue to meet it in the silence between stars. We can send more missions. We can build lunar bases. We can plant observatories in its dust. We can write instruments and poetry and code that call the moon not lost, but in orbit. Because while the moon drifts away, it also remains in step with us. Our tides still rise. Peril, our oceans still breathe. And for now, our history and our horizon still share the same companion. What we've already done already. Humans have sent dozens of missions. NASA's Artemis program plans to land new astronauts, including the first woman at the moon's surface. China and India have active lunar missions, studying the moon's ice, dust, and mineral makeup. Robotic landers dig through the regolith. Satellites orbit to map gravity fields. Seismometers listen for moonquakes. Telescopes scan from the far side, away from Earth's radio noise. In a way, we are not stopping the moon, but joining it. Its distance becomes not a goodbye, but a challenge. And humans, stubbornly soft-hearted, do not always obey the physics of farewell. What we hope to learn by chasing why chase a drifting moon? Because in its dust lies a map of early Earth. Because its craters hold clues to asteroid history. Because its poles may hide frozen water, a resource for future explorers. And because studying the moon helps us understand something larger. How planetary systems age. How time reshapes gravity. How orbits widen and relationships stretch. The Earth-Moon dance is a kind of cosmic aging, romance that begins in fire and ends in quiet distance. By studying it, we see our own future and the pasts of other worlds. The moon as archive. Think of the moon as an archive, a library with no atmosphere, no weather, no erosion. Footprints stay. Dust settles and never stirs. Radiation writes slow. Visible words on every exposed surface, and embedded in its rock are echoes of solar storms, magnetic pulses, and fragments of ancient collisions. We may never catch the moon, but we can read it like a final chapter still being written. The poetry of motion is their beauty in letting go. Perhaps the moon's drift is not a betrayal. It is a gentle physics. It's a slow ballet of mass and momentum in time billions of years. The moon will reach a point of tidal locking. Earth will spin so slowly that one side always faces the moon, just as the moon already shows only one face to us. A perfect symmetry. No chase, no drift. It's just a constant gaze. And eventually, perhaps even that balance will tilt, and the moon may slide further, fading into the dark like a silver fairy into fog. Can art catch what science can't? And so, even as rockets rise and data streams from lunar orbiters, even as we build habitats in craters and dream of lunar greenhouses, some part of us will always reach in other ways, through music, through mythology, per bedtime stories. Child, somewhere tonight, will ask their parent, why does the moon follow us when we walk? And the parent, without a calculator or telescope, will answer, because it loves you. And in that moment, the moon is caught, not physically, not forever, but fully and beautifully, for just a heartbeat. So can we catch the moon again? No, not with machines, not with nets of math or bridges of steel, but in stories, in memory, in the soft gasp when a full moon rises orange over the ocean. Yes, every night we catch it again, and again, and again, and again. It won't happen in your lifetime, or in your child's, or in 1,000 generations. But time does not forget. And gravity never stops whispering. One day, the moon may leave, not in drama, not in anger, but in the quietest way, by simply continuing what it's always done, drifting slowly, steadily away. When gravity lets go, the moon is tethered to Earth, bound by gravity, locked in an ancient embrace. But like all things, bound by invisible cords, the connection stretches, and with every tide, every tug, every turn, it frays just a little more. The Earth gives the moon energy through tidal interactions, a subtle transfer, push. The moon thanks us by leaving, not a leap but a faded, won't rocket into the stars. It won't vanish like a light turned off. Instead, it will drift further and further until its orbit becomes so wide that it's no longer stable. Eventually, millions or billions of years from now, some passing object may nudge it, a rogue asteroid shift in the sun's expansion, and the moon may finally step beyond the edge of Earth's influence, a final goodbye, one last orbit. Then nothing, a sky without a moon, imagine it, no silver disk rising above the ocean, no crescent whisper at dusk, no pale glow over the rooftops. The tides no longer pulled in rhythm would become erratic, weaker, but not gone. Earth would begin to wobble. The axis that once spun with quiet balance would now tilt without reason. Seasons might shift violently. Climate patterns would change. And though the sun still shines, something would feel missing. The sky would be emptier, not darker, but lonelier. The impact on Earth's soul, beyond the science, beyond the tides and seasons. There is something harder to measure. Grief. Because humans have not just watched the moon, we've lived beside it. It's been our calendar, our myth, our guide. It has inspired gods, fears, poetry, lullabies, love songs. To lose the moon is not just to lose a satellite, but a witness to our existence. Every ancient field tilled under its light, every kiss bathed in its glow, every night walk where it followed your steps like a guardian in the sky. Without it, the sky becomes something else, still vast, still beautiful, but quieter and less familiar, where the moon might go if it ever slips. Free, where would it wander? Possibly into a wider orbit of the sun, coming a lonely planetesimal dot, or perhaps in a twist of celestial fate, it might be captured by another body, Jupiter, Saturn, even Venus, or it could drift forever, a ghost moon tracing a solitary path through the vast, unfeeling dark. Would we try to bring it back? Could we? Not really. Even now, catching the moon is impossible. Its mass is too great, its path too wide, and our tools too small. And in the future, where it's lost, no amount of engines, cables, or dreams could reel it in again. We might build new moons, artificial ones, satellites that simulate tides and shine artificial light. But it wouldn't be the same. A sculpture is not a memory. A machine is not a companion. What the moon leaves behind, but the moon would leave echoes, fossil corals, tidal records, crustal scars, and in our art, our stories, our songs, its shape would remain. It would become a legend, like Atlantis, like the garden, like the great beasts we've never met. Children would look at old photographs, ask their grandparents, was there really something up there? And someone would smile and say, yes, every night. It washed to sleep. It's a timeline of farewell today. The moon drifts at 3.8 centimeters per year. In 50 million years, Earth's days grow noticeably longer. In 500 million years, tides weaken. Ecosystems shift. In 1 billion years, Earth and Moon reach tidal lock. In 5 billion years, the sun expands. Earth is scorched. Beyond, the moon may escape, or burn, or be buried in stardust. A long goodbye, written in orbits. Not words. The last night with the moon there. May come a night, one night, far beyond human memory, when the moon rises for the very last time. The world would not know it. There would be no trumpets, no weeping, just a silent climb, a final glow. And then a horizon that forgets it. In the morning, it does not return. And the sky learns to live without. A moon in the mind still. Long after it's gone, the moon will remain in our consciousness, like a scent that triggers memory, like a song from childhood. We'll recreate it in dreams. We'll write it into language. We'll fold it into the myths of far futures. Some distant species, exploring an archive of human history, will see lunar calendars, moon gods, tidal studies, and they will wonder what kind of world we lived on that had such a luminous companion. The moon's gift was always time in the end. Perhaps the moon's greatest gift was not light, or tides, or poetry. It was time. The moon slowed Earth's spin, giving us longer days. It stabilized our tilt, giving us seasons. It made life more possible and more beautiful. Without it, life might never have taken hold in quite the way it did. So when the moon leaves, it will not take those gifts away. It will simply remind us how fragile they were and how lucky we were to be loved by something that never even spoke. Even if the moon drifts far, even if it vanishes into distance in time, the sky will still carry its memory, not in photographs, not in formulas, but in the rhythms we still live by. The tide still sighs against the shore, as if remembering a voice that used to call it. Oceans still rock gently, like they're being cradled by an absent parent. And even if the moon is no longer there, its fingerprint remains on every wave, every shadow, every dream. The echo of light. There's something peculiar about remembering light. Long after it's gone, you still feel its warmth. You still squint at its trace. The moon's glow once traced the outline of every city rooftop, every tree on the horizon, every child staring up from their window, even without its presence. The shape of its glow lives on in how we light our stories. Echo its silver. Lighthouse beams mimic its comfort. Even poetry reaches for its glow when trying to describe the quiet dot it left the light behind in our language. The silence, it taught us more than its glow. The moon gave us silence, not emptiness, but the kind of silence that carries meaning. The silence of reflection, of stillness, of awe. The moon didn't speak, but it taught us to listen, to wait, to breathe slower, to trust that some things unfold, not with noise, but with gentle movement, in a world that rushes. The moon was a reminder that slowness is not failure, it is grace. So even in its absence, the lesson lingers, sky lore and memory long after it's gone. The moon will still appear in stories. Children will whisper about it like a bedtime myth. There once was a pale stone in the sky, they'll say, and it followed the earth like a loyal friend, and it made the oceans dance. It made wolves howl. It watched over every single night. Some may not believe. Some may search for proof, and in the searching, the moon lives again. Every planet that spins without a moon will be compared to ours. Every tideless sea will be studied with longing, because once we had a partner in the sky, and that story is too beautiful to forget. Time still bears its name, even our calendars remember. Months named after moon cycles. Words like lunacy, crescent, eclipse. They all carry traces of a world that once shared the sky with its twin dot. And when you look at old architecture, ancient symbols, buried artifacts, you'll see crescents carved into stone, goddesses with moons above their brows, graves pointed toward lunar paths. The moon left a mark not on the surface of Earth, but in the bones of our time. A planet that remembers even. The planet itself holds on. The crust still cracks with ancient tidal stress. Glaciers still bear the erosion patterns of lunar-driven rise and fall. There are underwater caves shaped by currents born from lunar pull. There are mountain shadows that once caught moonlight and nothing else. The memory of the moon isn't just poetic, it's physical, etched into the structure of oceans and valleys. Even when we forget, Earth does not. The moon, as a measure of Losset's absence, will teach us something new about grief. Not dramatic loss, not sudden pain, but the slow ache of something gently leaving for a very long time. A goodbye that takes eons. That teaches you what it means to feel something pulling away, inch by inch, year by year. The moon won't die. It won't break, right? Won't betray. It will simply leave. And in doing so, it will show us how deep love runs when it doesn't have to shout. New moons will come in the vast future. Other moons may be born, fragments from collisions, artificial satellites reshaped into new rhythms, orbital colonies, perhaps shimmering with the light of human intent, but none will be the same. They may serve function, they may reflect light, they may even stir tides, but they will not carry the weight of memory like the one we knew. Still, we'll call them moons, because the first one taught us what that word means. The cosmic lesson in the moon's leaving. There is a final gift. It reminds us that everything drifts, that even the most faithful companion moves on, that nothing, not even something as large as a satellite, as constant as night, stays forever. And that's okay, because meaning isn't measured in permanence. It's measured in presence, in how something made you feel while it was here, in how it shaped your world even after it was gone. The moon may drift away, but its orbit still defines us. Tonight, it's still their step outside. Even now, tonight, the moon is still above you. It may be full, or just a sliver, or hidden behind clouds, but it's there, still circling, still glowing, still watching you as you fall asleep, as you dream, as you wake again, still sending its light to lovers, to poets, to scientists, to children with questions, still pulling the tides, marking the time, reminding us quietly that it has not yet said goodbye. Not yet. So while it's here, look up, because someday someone may ask, what was it like to live on the world that had a moon? And you'll be one of the ones who remembers.